Hey everybody, this is Alex Merced, and welcome to another episode of Gnarly Data Waves presented to you by Dremio. As usual, here I am as your host, and today, me, Alex Merced, Senior Technical Evangelist here at Dremio, and Vishnu Vardhan, Director of Product Management for StorageGRID over there at NetApp, we're going to be talking to you about building the next generation Iceberg Lakehouse with Dremio and NetApp. And this is particularly exciting because this is really talking about the cutting edge of Lakehouse architecture and what's possible when you embrace Lakehouse architecture. And speaking about Apache Iceberg, here at Dremio, we have been advocating, have been educating on Iceberg pretty much, before it was cool. And basically, one of the first platforms to embrace Apache Iceberg, created some of the earliest online Apache Iceberg education materials. We are the authors of Apache Iceberg, the definitive guide, and the creators of one of the first open source lake houses, open source catalogs for Dremio in the form of a Nessie. Now, also in that regard, we don't stop there. We're gonna keep educating about Apache Iceberg. We're gonna talk about Apache Iceberg today, but if you want to learn the whole architecture, everything about it, we will be doing an Apache Iceberg crash course, 10 sessions, starting this week, going through July 11th, October 29th. You can scan this QR code to get involved in those sessions. But with no further ado, let's begin talking about today's subject of Dremio and NetApp and building that cutting edge hybrid Apache Iceberg Lakehouse. So in today's agenda, we'll be talking about market news, just talking about some of the changes in the market that really make this topic particularly pressing in today's world. And once we establish that, sort of like why Apache Iceberg and why Lakehouse is like what makes it when you combine these technologies such a powerful step toward this Lakehouse architecture, and how Dremio and NetApp put together take that even a step further. And we always wanted to be doing that, right? Taking our data infrastructure a step further. And we'll do a deep dive and just saying, hey, what do these two platforms have to offer when you use NetApp as your storage layer and Dremio as your analytics layer? And just take a look at a couple, great examples of these things in action, of the benefits that different sort of customers and entities have had when they've embraced this combination, with examples and case studies and the different use cases for Dremio, NetApp, and that hybrid Apache Iceberg Lakehouse. And just to kind of better understand sort of like the problem that this is solving is like you have to think about sort of the current status quo lifecycle of data. What happens? We have all our data sources, which in our data is found in a disparate array of databases and data warehouses and data lakes. And oftentimes we take those original sources, the databases and log files and other things, and we have to ETL them through a complex chain of data pipelines into data lakes, and then through another set of complex chains of ETL pipelines into data warehouses, all just to land them and deliver them to our data consumers for BI, for AI/ML. The problem with this is just the more pipelines you have, the more you delay the delivery of that data. Okay, and you're going to see that we can simplify that, and not only simplify and be able to get that data faster to those who need it by shifting left, by sort of removing that dedicated data warehouse and using our data lake as our data warehouse, aka data lakehouse, but it's also going to reduce costs because you're reducing the amount of compute you're spending on ETL jobs, you're reducing the amount of storage you're spending on having to store multiple copies of the data in different systems in the data lake and the data warehouse. Overall, you end up with, and then just faster delivery of that data. So you get faster time to insight and reduce costs. It's a win-win when you embrace data lakehouse architecture. And when it comes to data lakehouse architecture, one of the big choices you have to make is a table format. And one of the things that's been established really recently is that Apache Iceberg really is the winner when it comes to the sort of the default, the standard bearer when it comes to a table format for how you represent your data sets in the data lake. And there's a couple different news items that really emphasize this. One is Databricks. Now, Databricks created their own table format called Delta Lake. But despite that, they still ended up purchasing Tabular, the company founded by the creators of Iceberg, for over $1 billion. Okay, a multi-billion-dollar purchase. If that doesn't signal that the need to embrace Apache Iceberg, the need to adopt Apache Iceberg is that prescient when Databricks makes that purchase, I'm not sure what a better signal you can find. And then you also had Snowflake basically jumping in on the open source bandwagon by announcing their open source catalog, Polaris, a huge announcement, okay? And you're starting to see sort of movement towards two different things, or a couple different things, open, Iceberg, and Lakehouse, okay? Basically, these are three things that we at Dremio here have been advocating for years, but over the years, you're starting to see companies like Snowflake start moving more towards Lakehouse and open, and you're starting to see companies like Databricks moving more towards Iceberg. Basically, everyone's sort of really converging in that sort of open Iceberg Lakehouse story. So never a better time to really you could never move forward with Iceberg as confidently as you can today. The signals are there that this is the format, this is the architecture, this is the way forward when it comes to sort of taking that leap with your data. And a couple of just sort of other signals of just why the Apache Iceberg project has kind of earned this status is one, it's an open project. It's a community-run project. So there's no one commercial entity that can just flip the project overnight. So that you can build confidently with certainty going to the future because you have big name companies who are contributing to the project, but they're all contributing through cross diverse contributions as a community. On top of that, with Iceberg, queries are faster. Okay, so basically when it comes to data lake queries, Iceberg makes those queries nice and fast because of the metadata that allows you to kind of quickly identify which files you need to scan for any query. Changes are easier because of the way the metadata is structured in Apache Iceberg. You can do granular inserts, updates, and deletes, easily add data from files to your Apache Iceberg tables, especially with the tools like Dremio that work really well with Apache Iceberg. And the result is less work for your data team, which means instead of spending a lot of time maintaining the world they have now, they'll have more room to expand that world, to scale out and take on new projects because you're not spending as much time having to fix what's already there because what's there works. So fewer of those data tickets. And again, lower compute and storage costs. And the cherry on top, basically, because Apache Iceberg is an open format, you're not locked into any particular vendor. If you need to change who you're doing any particular aspect of your data story with, you can change it and not have to recopy and reduplicate all your data and do these complex migrations. Once you're in Iceberg, you can stay in Iceberg and still evolve your Lakehouse architecture as time goes on. And Iceberg has one of the broadest ecosystems of tools that you can choose from for this, making it a very compelling choice when you're looking for that sort of open avoidance of lock-in. So with that, let me bring in Vishnu to tell you about the first half of this amazing solution when we make these Iceberg Lakehouses happen in NetApp StorageGRID. So with that, I'll let Vishnu take it over from there.
All right, thanks, Alex. So with that introduction that Alex gave about how Iceberg is now the standard and how both Databricks and Snowflake are adopting Iceberg. And there was this transition where you had this multiple formats, but now everybody just comes into Iceberg as the one format. Object storage starts to become much more relevant, right? And that's because Iceberg is fundamentally an object storage based format first. It really shines with object storage. And so it's really important to kind of understand your object storage solutions in that perspective. And so we'll talk about StorageGRID, which is NetApp's leading object storage format. And then we'll talk about Dremio, and then we'll kind of put all of this together. So StorageGRID from NetApp is an object storage solution that scales to 800 petabytes of capacity in a single cluster. So one cluster scaling to 800 petabytes, having 300 billion objects in that cluster. And that cluster can span across multiple sites. So we can span 16 different sites, just one single cluster, and create a single global namespace, which means that you can go and access that data from any of those global sites. And this is active access. So you can go in and read the data, write the data in San Francisco and read it from New York and be available that very second. And you can have all of these reads and writes going across your entire object storage infrastructure, right? So that's a massive scaled single global namespace for your object storage. So StorageGRID does that. I think it's by itself fundamentally differentiated as an object storage platform. But in addition to that, we provide a policy engine, and I'll speak a little bit about that. It's extremely flexible to deploy. You can mix and match, and you can run it on virtual machines, or you can run it on appliances that we provide for simplicity. It offers up to 15 nines of durability, and you can configure it, and it's configurable. And finally, a lot of your storage doesn't really stay in the object storage. You need to be able to move it around. You need to be able to move it to other systems. You need to be able to move it to the cloud many times, and really get multiple tiers of storage, because each tier has its own economics and its own value proposition, right? And so StorageGRID lets you do that. And when you combine that with Dremio, we'll show you how we built how the solution can be really, really compelling. So if you go to the next slide, it'll kind of show you how, first, from a policy perspective, if you have 800 petabytes of data, managing that is really hard. And so if you have a large lakehouse, you really need policies that will tell you how to control that data. How do you, and that's really important because that lets you define where the data lives. So do you want a copy, for example, in a particular data center? Do you want that copy to be, within a particular region to meet data sovereignty guidelines? And so constrain data that is in Europe only in Europe, for example, right? And so define policies that can do that versus how long you want your data around. Much of your data is going to be cold. There's some that's going to be hot. And so you want to distinguish your cold data from your hot data and really treat them differently. You want your cold data to be extremely low cost. Make sure that that's the first value prop that you give your customers. And then when they access it, it's just transparent. They don't really know that you have tagged the data, you have identified the data as cold, and you have given it some special treatment, right? Your user should just access the data and just get it. And it's just be transparent to them. So the policy engine lets you define how long it is stored and how it is stored to get your costs lower. And lastly, really be secure, right? How do you improve the durability of your data? Some data sets you want extremely durable. Others, less durable, right? And so define that in a much more simple way. And so this is a simple screenshot that says how, with different conditions and policies, you can really apply very granular rules on your data. Now, some systems still do this, but what really needs to also happen is that your environment is always dynamic, and you need to go in and be able to change these policies and apply them retroactively on data that's been ingested prior. And so with StorageGRID, you can actually do that, where you have a data lake, you have some data sets that are now cold, you want them to be made hot again. You can go in and change a policy and then make all the data hot, and now all your queries are back to being really performant. That could mean, for example, moving from HDD to flash storage, and doing it transparently, so your applications don't really know that they just have a namespace, they just access the data, and you can decide, is it on flash, is it on HDD, and then move it around as an example in terms of improving performance. So I think that's the policy engine that StorageGRID provides that's extremely differentiated for lakehouses. But that's not sufficient. And so if you go to the next slide, you will see that apart from the policy engine, we of course provide basic bucket management and the basic S3 API. So and when I say basic, the StorageGRID platform has all the S3 APIs. It's just fundamental that an object storage platform provides S3 APIs. But that's not sufficient, right? When you create this large infrastructure, it's really important in terms of how do you manage security? How do you manage denial of service attacks on your grid? Can you prevent them? Do you have traffic shaping? Do you have quality of service? Can you prevent different untrusted and trusted users from hitting a particular endpoint? If you have s3.yourcompany.com, you want to allow only particular people to access that endpoint and not others, and you may want to prevent that. And so really the whole load balancing tier is very fundamental in terms of driving a very secure infrastructure. You of course want this to connect out to your entire identity framework in your company and be able to apply granular policies. And so that's something that you need to be looking at in an object storage platform. How do you build this internally? How do you, if you have so much of storage, how do you do chargeback internally? Do you have billing and metrics to be able to do billing internally? And so that's something that you need to think about. And these are things StorageGRID has, and I'm just posing them as questions so you can kind of understand the value that StorageGRID brings. A big part of this large infrastructure is audit logging and being able to really look at all the actions that are happening in your storage system and be able to build an audit trail that lets you prove whether your solution is secure or not. And so that's something that you want to be looking at. Lastly, security is fundamental. You need to have multiple levels of security, and you want that to be all. We have customers that sometimes enable all security levels because that's the threat factor that you want to be considering. So very flexible, as I said before, multiple ways to deploy it, whether it's in appliances, VMs, or bare metal, and many ways to kind of move your data around to different clouds. That provides an object storage platform that you can use for your data lake. So we'll now talk a little bit about Dremio, and then we'll kind of put these two things together. And so, Alex, over to you.
Hey, everybody. But bottom line, you're trying to see the shape out the sort of the flexibility of these platforms and the flexibility of when you start building this data lakehouse. And Dremio adds even further flexibility. Generally, Dremio is what's called a lakehouse platform. So the idea here is you want to use your data lake as sort of your data warehouse, as sort of that center. So what you need is a tool that kind of wraps all the pieces and components of building a lakehouse and puts them in sort of one nice unified way. And Dremio does this with sort of 3 tiers of service, which include unified analytics, our SQL query engine, and lakehouse management. And let's just kind of click in and see a little bit deeper each of these sort of tiers of service. So we have unified analytics. So the idea here is you're not going to have all your data in one place. So Dremio needs to be able to interact with your data wherever it is. And this is where, again, something like NetApp StorageGRID works really well, where it can also sort of move your data where it needs to be. So you have this analytics layer and storage layer that kind of gives you that flexibility. So Dremio is able to connect to databases, data lakes, data warehouses on-prem and in the cloud. So that way you can reach your data wherever it is and be able to access it really quickly and be able to model it. So in that case, if I have a Iceberg table on my data lake and then maybe another table in Postgres that I need to join to create a particular object or data asset that one of my consumers need for a BI dashboard, I can model it in Dremio without having to move the data. And then that basically then can be delivered to serve whatever data purposes you need. On top of it, you have deep governance and security at that access layer as well. So basically all these different data sources that are accessible through Dremio can then be governed using role-based access controls, using column-based masking, row-based masking, along with many tools for auditing and querying and being able to see the lineage, as along with other security features like single sign-on integrations and whatnot. So you have this really robust access layer to access the data across many different sources. But when you query that data, you have a powerful SQL query engine to then query that data that can federate queries across those different sources, but also has really powerful acceleration features that work across all those sources. So in that case, then that comes in the form of reflection. So the Dremio query engine already is the most price performant engine on the market in the sense that basically it can execute the same query at a lower price because it's so fast. But when you need that extra juice, there's a feature called reflections that provides essentially a relational cache. Essentially what it's doing is it'll cache Apache Iceberg representations of key data sets. So maybe I have a Postgres table that I'm looking to accelerate. I can turn on reflections and it creates sort of an Apache Iceberg version of that table that it can substitute when that table is queried in the future. But not only that, it'll actually update that materialization and then figure out when to substitute it. So you don't end up having what you have with other systems with things like materialized views and cubes, where you end up creating all these different versions of the same data set, and the data analyst has to kind of juggle them all in their head and know which is the right one to query for which types of queries. In this case, Dremio will figure out, hey, which of these reflections is the right materialization for that query, and make sure that materialization stays up to date. And again, we also have something called the columnar cloud cache, which is specifically designed to accelerate work with object storage. So essentially on nodes where the Dremio cluster is running, it's essentially caching in the NVMe memory, regularly access like columns or rows from different Parquet files that you're accessing on a regular basis to accelerate queries and also can reduce costs when you're thinking about like sort of network access costs and things like that. So the SQL query engine is fast and performant and also helps reduce costs. And last, we have lakehouse management. Because if you're using your data lake as a data warehouse, one of the things that data warehouses and databases do under the hood that we oftentimes take for granted is that it's oftentimes managing how that data is stored. So cleaning up data we don't need anymore, rewriting data that needs to be rewritten as we write new data to it. That doesn't automatically happen in the data lake. So in that case, we oftentimes would have to run our own sort of regularly scheduled maintenance operations. Now, Dremio makes this much easier in sort of two ways. One, it makes running those operations really easy through easy to access SQL commands like optimize and vacuum that allows you to manually maintain your tables really easy. But even better, you can automate that. Well, with Dremio's enterprise data catalog, you can then schedule sort of a regular cadence of maintenance. So that way you just don't have to think about it. Your Lakehouse Iceberg tables will just sort of work. They'll be performant, and you won't necessarily have to worry about, runaway storage because Dremio's actively expiring snapshots and cleaning up data files you no longer need as you go. So you get all the benefits of that Lakehouse paradigm, and you're going to minimize the amount of work it takes to sort of implement it, because Dremio as that data lakehouse platform makes that whole implementation much, much, much easier. So that's like the Dremio platform. And because Dremio can connect to on-prem and cloud sources, Dremio becomes a really key component to creating that hybrid Iceberg lakehouse, because it can connect all those data sources from wherever that data is and provide that nice access layer where you can govern that data, model that data, and deliver that data to wherever people need it, whether it's a Python notebook or a BI dashboard tool like Tableau or Power BI. Dremio can deliver the data there, act as that layer in between that provides you that reflect those accelerations, that provide you that performant SQL query engine, that provides you that semantic layer to model that data, provide you everything you need to make that data easily deliverable in that lakehouse fashion, which is, well, really cool. So thus begs the question, these are two really cool platforms that do really awesome things to make sure that my data in my data lake is flexible, affordable, and performant. And why not? How do we pair them together and make something even more awesome? And so let's talk about what happens when you put Dremio and NetApp together. You end up having something like this. You bring in your data in the data lake, and Dremio is really flexible. So when it comes to helping, or really a data lake is really flexible, and you can bring your data into Apache Iceberg tables and store it all sorts of different ways. You could use Dremio to bring that data in. We have features like SQL language like copy into that makes it really easy to copy data from JSON and CSV files into an Iceberg table. We've just introduced auto ingest pipelines that allow you to basically set up a regularly scheduled ingestion job from object storage. You can use Kafka to stream into Apache Iceberg tables and other streaming tools. You can basically use something like a create table as with Dremio to just move data from any other Dremio connected source into an Iceberg table, or use other integration or other ingestion vendors like Airbyte, Fivetran, Upsolver to bring that data into your data lake. But once the data is in your data lake, so again, stored in your StorageGRID layer that provides you all that those key tiering features and those really cool policies. But on top of it, you have Dremio on there providing that access layer, so that way it makes it easy for people to access that data wherever it lies and however you move it. And then again, you get reflections to provide that acceleration to then deliver it to your favorite tools. Okay, so you get this really powerful, affordable, fast lakehouse. So basically, again, Dremio comes around providing you unified analytics, being able to connect all your data sources wherever they're at, a powerful query engine that allows you to federate queries across all those data sources, and lakehouse management, allowing you to manage those lakehouse tables so that way it truly feels like a data warehouse experience with ease of use and performance. And that's all built on top of the tables you have that are stored in the Iceberg format on your NetApp StorageGRID. And NetApp, as Vishnu would tell us, brings you so many different benefits, such as.
Right. So fundamentally, you have this data sitting on StorageGRID, and firstly, right, just if you compare from the cloud to on-prem, you have a significant cost saving. But compared to other storage object storage options, StorageGRID with its ILM, you can control how that data is being stored. So, for example, if you store 2 copies of data or 3 copies of data, that's going to have a certain cost. If you erasure code it, we can, instead of having 3 copies, now you have 1.5 copies, right? And so that's a 50% cost saving. And you don't have to erasure code at 1.5, you can erasure code it even more. That makes it even more efficient. So StorageGRID can actually lower that cost significantly for you in terms of what that storage is. It definitely has all of the S3 APIs in terms of bucket management. So you don't have to use StorageGRID just for your data lake, but there can be other use cases in your enterprise that you want to also use StorageGRID for. So So that lets you use the object storage as a general purpose system across your entire enterprise. If you go to the next slide, if you click again there, Alex, yeah. So security is really key. But before that is even preventing misuse. So denial of service attacks and really restricting that, especially if you have a single storage system and you have many users on that, you want to be able to restrict who can do what, right? And so that's what you can do with StorageGRID. We of course have significant performance. Dremio is amazing, and we'll kind of talk about some of Dremio's performance. But compare that when you pair that with StorageGRID, you get an even more performance system. And lastly, security is not negotiable, and so really multiple levels of encryption that the object storage platform can provide.
Cool. And thank you so much for that. But basically, bottom line, let's just kind of keep exploring sort of like the partnership between like Dremio and StorageGRID and how these things like work amazing together. So just reinforce sort of when you pair the two together, what aspects is Dremio managing for you? So Dremio can bring a lot of things to the table as far as helping you manage user access. So essentially, basically Dremio can act as that access layer on top of where your data is. So essentially, your end users are given an account on Dremio, and they can only access the data that you've given them permission to access from the Dremio platform, which then has access to your StorageGRID and other data sources. And again, you can use role-based access controls, column masking, row-based masking, all in providing that sort of fine-grained privileges using Dremio. But then you also get version control. Dremio's enterprise catalog actually provides catalog versioning. So you're actually able to create multiple versions of your data catalog. This can be useful for one, like isolating ingestion. So that way you say, hey, you know what? I'm going to make changes to my data, but I want to isolate it into a branch until I'm ready to publish that data, making it much easier to kind of make changes to your data and publish them in a consistent way. You could use it to create zero copy environments. So for one example is like a financial company who has to do certain stress tests on their data on a regular basis, they can create essentially a zero copy clone of the data by creating a branch, modify it for those different stress test scenarios, run the stress tests without having to modify their production data. Even though they're necessarily working from the production data, they're not altering their production data because they can just dump the branch afterwards due to Dremio's version control features. And on top of that, you can recover from any mistake because you can always roll back to previous versions of the data. You have table optimization. Again, those Lakehouse management features where Dremio is going to constantly clean those tables up. So rewriting data files so that way they're more in a more performant and optimized form, and expiring old versions of the table so that way you can clean up data files you no longer need based on your data retention policies. So that way your data just works. It's just the way you want it. And again, provide that isolation so that way basically transactions don't interfere with each other. Again, you can do that isolation on branches and so forth. And with that, Vishnu, tell us a little bit about some of these benchmarks.
Yeah. So as we began to work with Dremio, we decided to do some testing ourselves to validate how Dremio works with StorageGRID. So we compared three solutions. We compared Hive with Spark running on Delta Lake, as Alex touched on the Delta Lake format earlier, and then we tested Dremio with Iceberg, of course. So if you look at the bottom line, right, Dremio is about 20 to 25 times faster than Hive running on a Hadoop environment. And so if you look at why it is and why is that significant performance delta of 25x, it's really coming from the list head and the two kinds of head operations, right? So Hive is really doing like 1,000 times more list operations than Dremio is. Even if you look at the head operations, they are significantly more than what Dremio does by orders of magnitude. And the reason is because the Iceberg format has been uniquely developed for object storage. And so you can see that where the Hive systems are just not able to scale while Dremio is extremely fast, right? And so this kind of plays into the next slide where we'll kind of talk about the overall benefits that you're seeing. just straight away we see a query performance of at least 10x. As in the TPC-DS benchmark that we saw for the 25x delta. But when you combine that with the cost economics that StorageGRID is able to do with its policy engine that lets you store data at different levels of cost, and combine that with Dremio's query performance and just the overall simplification that it's able to drive, you're able to get a 9x price performance improvement and a 75% savings in your ETL costs, just because you don't have to be moving your data across all of these different systems. And with this one data lakehouse architecture, it just simplifies all of your engineering. Net, we are seeing up to a 50% better TCO with these two solutions together. Just a phenomenal improvement in terms of what your data lake is now costing.
Awesome.
So
And but
go
bottom
Alex.
line, all good. But bottom line, there's like really a couple of really key places where you can be using Dremio, and StorageGRID put together. So bottom line, if you need a Lakehouse, this is a powerful combination. As you can see those numbers, as far as like TCO and performance benefits. But another key place where basically this combination becomes really helpful is if you already have an existing on-prem Hadoop Lakehouse and you want to move in that process of sort of modernizing your Hadoop infrastructure. Basically what happens is you can move to Dremio plus StorageGRID and end up with sub-second query performance and a 10 times better price performance. You can move to govern self-service analytics because again, those you get all those access features that you get at both layers. Okay, with the fine-grained policies that you get with StorageGRID and the fine-grained access controls you have on the Dremio layer. So you get real control, real security to make sure that no one's accessing that data that should not. A unified view, because again, Dremio can then connect all your different data sources in the cloud and on-prem and provide that unified view so that way everyone sees where their data is in one place. And the ability to sort of scale that compute and storage layer. Basically, you scale your Dremio and your NetApp based on your needs separately. And basically end up getting improved overall data management, and you reduce the complexity of your overall infrastructure, providing a very, very powerful result. So again, migrating from a legacy Hadoop data lake to a modern NetApp StorageGRID and Dremio Lakehouse environment can bring you lots and lots of benefits. So what we'll do is now we're going to take a look at how NetApp did this with their Lakehouse. So I'll bring back Vishnu to talk about NetApp's actually showing this solution in their own data lake.
Yeah, so we didn't partner with Dremio first and then build the solution. What we actually did was we actually used Dremio and StorageGRID first together inside in our own infrastructure, and then we realized that this is a really compelling story. And then we started to put this whole solution together and said, hey, this is great. We should just not keep this inside the house. We need to tell other people about it. And so that's kind of the genesis of this overall partnership. And so in this particular case, how this all started was we have an internal telemetry system called ActiveIQ. ActiveIQ is a massive system. It receives about 10 trillion data points every month from hundreds of thousands of systems that we have outside. So we collect all of this information. We really use it for three different things. We use it to provide a support experience for our customers and make sure we can analyze their systems and help them fix issues. We use it to provide insights to our customers to say, hey, you can do these 5 things to improve your utilization of your system or make it perform better, right? And so we provide insights to our customers to use. And then we use it inside internally for our own analysis of how our customers are using our systems, right? So very critical system that's really defines how we do our business. And so that's been around for a while. It started off as flat files, and then we moved to a Hadoop infrastructure. But we had a bunch of problems with that. With Hadoop, we had to scale both storage and compute together. We could not scale storage, and our system was just growing. So we had to keep adding cores for us to be able to really scale the storage system underneath, and that was expensive, right? And so first was just the scaling was not cost effective. The second challenge we had was in terms of governance, both in terms of the infrastructure where particular Spark jobs could run, and they could they could starve the Hive queries. And so we were not able to granularly control. There were some controls, but they were not granular enough for us to say, we don't want this Hive, this Spark job to run and take over so much compute. We want to share this with the Hive query. So we didn't have that kind of control. We also had issues in terms of being able to granularly control row and column access. Hadoop does have additional tooling, but that was a little bit more complicated for us to kind of do. Lastly, was just performance. We were seeing 45-minute query times with our Hadoop infrastructure, and that was just extremely painful. So to kind of address this, we looked at Dremio. We looked at a bunch of vendors, and then we finally worked with Dremio to move this solution from the Hadoop infrastructure to Dremio. And when we moved it, we didn't just move it so we actually created 2 copies of the system. We copied the data over from Hadoop to Dremio, and we felt that was safer as a way to move the data. And we started to use StorageGRID as the underlying storage system, and Dremio as the query layer. After a little while, we realized we don't really have to move the data, create a copy. Dremio is actually able to operate with 2 different systems at the same time, and be able to seamlessly do the migration in the backend. So that's something that we kind of realized. But initially, when we used it, we copied the data over. As we finished the migration, and when we finished it, we were able to give dramatic savings, right? We were able to save up to 60% of our costs on this system. Our query times dramatically reduced to about 2 minutes from what was 45 minutes. And so those savings were significant. But and as to wrap this up, what was also very interesting was the effects it had on our overall data lake. We started to get higher satisfaction from our users. So we started to also get more users using it, and we started to have more data come in. And so it just became a very self-fulfilling and a good change in terms of how the system started to grow more and more, and we started to get more usage and with much lesser. With much higher user satisfaction at much lower cost. So just a great solution, and I think was the basis for all of this, that we're talking about here today.
Awesome. I just love that story. It's just lovely to see like amazing technologies achieving amazing results. And it's not the only story. I mean, here we have another story of someone doing that sort of Hadoop modernization movement, who's a company in the global 100, it's a global 100 financial institution. And they started off with an existing large legacy on-prem Hadoop data lake. They had no plans to move to the cloud. That wasn't necessarily the goal, but they wanted to kind of get more of their existing on-prem infrastructure. Okay. And what they ended up doing was adopting a StorageGRID in Dremio, a Lakehouse. And basically what they did is they used Dremio for their financial data landing zone, basically acting as their single source of truth, giving them the ability to sort of join data from their NetApp StorageGRID data on their lake to, also be able to join their existing Hadoop as they phased it out or as they modernized from and moved away from Hadoop. They were able to kind of connect both sources and make that transition much more seamless, because basically your end users didn't have to really worry about where the data is. They can see the data sets they have access to. And as the migration happens behind the scenes, it doesn't really change the workflows of your end users. And with Dremio Semantic Layer, again, all that data is nice and modeled, and they just see the data sets they need to have access to, and they're not necessarily concerned with where that data is coming from, making that transition much easier. And then also providing sort of an audit trail of where these queries are coming from, so that way they can still provide information to the FTC. And with their NetApp storage plans, they're able to reduce their previous Cloudera data platform costs quite a bit, and eventually move entirely onto StorageGRID. And basically, it's all led to again, reduction of costs, increasing of performance, reducing of your time to insight, making a faster time to insight, and overall just a better experience. So this is for something that stays strictly on-prem. So whether you're building a hybrid solution, cloud and on-prem, or strictly staying on-prem, there is a great story and great outcomes that happen when you mix Dremio and StorageGRID to modernize your lake. And here, one more example, this is from a Fortune 10 customer. Basically, they had a 75% TCO savings. So that's 3 million savings in just one department at this particular company. But essentially, we take a look at their world before. What used to happen is that they would have to ETL data from their data lake and then ETL that data into Snowflake. So you have sort of multiple data movements. And then all these transformations would have to then happen within the data warehouse, okay, where the compute costs are a little bit more. And then you're increasing storage costs as you do those materializations layer by layer through those transformations. So you would have a lot of costs there. And then that would create 700 million records. And to do all that, the resulting BI dashboard, even after doing all of that, would still take 3 to 4 minutes a click. So essentially, they would, turn a knob, click a toggle to change the values in the BI dashboard, and it would take 3 or 4 minutes to refresh. So they were spending a lot more and really having a not very pleasant experience on their BI dashboards. So then they moved over to Dremio in this kind of setup that you see here on the right, where basically all the data just stayed in the data lake, okay? And they just modeled the data. They did the transformations virtually using Dremio right there on the data lake. Okay, so there wasn't all those copies of data. There wasn't the more expensive compute to do all these transformation. And basically they didn't even have to do, things like reflections. This is just direct queries right off their lake. And they were able to achieve 5 to 15 seconds per click. So basically, they went down from having to wait 3 or 4 minutes for that BI dashboard to update, along with all the costs of just getting the data in place to do that, to reducing their costs because they're reducing the duplication of their data, and reducing again the speed at which that BI dashboard. And so this is sort of the benefits when you use Dremio on top of your data lake and basically treat your data lake like your data warehouse, aka a data lakehouse. So again, just making that case for why you want to make that move to sort of the data lake infrastructure and why everybody's moving in that direction. It's no longer just a few people screaming on a mountain, Lakehouse is the way. Everyone, and as we saw in those news bits at the very beginning of this presentation, everyone's moving to the Lakehouse. Everyone is looking in that direction, and now is never a better time to start making those steps. And with Dremio and StorageGRID, you're going to get that best-in-class TCO. You're going to get that best price performance. You're going to get that fastest query performance, and you're going to get simplified data engineering and management. And again, there's no better time to start than today, moving in that direction and future-proofing yourself and getting all those nice results. So here are going to be a bunch of QR codes so that way you can get access to a case study from NetApp, from a case study regarding the Dremio and StorageGRID solution, and some other things to consider when you're moving from Hadoop to a data lakehouse, so that way you have all this information to begin planning your journey. Of course, we would always be glad to have Dremio and NetApp would always be glad to sit down and have a meeting to help you architect what that journey looks like for you. So, basically, we had a poll earlier to see if you would want to meet. But also, if you have any questions, please do put them in the Q&A box there in the menu bar below, so that way we can answer those questions as we wrap up this presentation. But I just want to also say thank you for being here today, and also thank you to Vishnu for being on the show this week. This was a great time, and I always love hearing about the benefits of StorageGRID, and I also especially just love seeing how basically that not only do they have this great combination between Dremio and StorageGRID, but how well it worked for them as well in house. It's such an amazing story. But with that, we have a question. So when will Dremio have Spark capability plugins? So on this question, so basically the way I'm reading this question is like, hey, when would Dremio have some sort of way to write sort of Spark, basically be able to write like data frame type logic in the Spark API? So basically be able to take your PySpark code and run it against Dremio compute. I wouldn't say that's on the existing roadmap. Dremio is definitely a very SQL first platform, although technically, the open source components for making that a possibility are there. Essentially, the path to that for any open source devs that would like to build these out. Basically, it would be a SQL. There's a library called SQLglot that allows you to transpile between different SQL dialects. So creating a Dremio language in SQLglot would be step number one. And then with that, you're able to then build out either an IBIS backend, or there's another one called SQL. I think it's called SQL Frame that's more specific to the PySpark API. And then you then essentially would basically have what you're talking about there, and doing it all through sort of open source channels. So that's a possibility. Now, another question: how does this compare from setup and upfront costs compared to public cloud storage options? So I'll pass that off to Vishnu on your thoughts on that question.
Yeah. So firstly, I just want to thank you for having me on. I didn't get a chance to say that.
Thank you.
Sure. So there were two questions, I think, and I'll kind of address them both together. I answered one of them in chat, but I'll kind of voice over it. So there was a question about how does StorageGRID differ from AWS S3, right? And is it migratable to other vendors? Um, so StorageGRID is an on-prem version of AWS S3. The reason we have multiple customers do that is because it's just so much cheaper to run something on-prem. You don't have egress costs, you don't have access costs on every API. It's just much more cheaper to run things on-prem. And so StorageGRID does that. There are use cases where you want to be using the public cloud, for example, Glacier, and StorageGRID can tier out to Glacier. So dramatic cost reduction. We have multiple customers that move, petabytes of data on-prem just because they realize it's just so much more expensive. It is a separate product, but as we said, we work together, and so it's not bundled into Dremio, but it's a separate product. So I think there was the other question is how does this compare upfront setup and from setup and upfront costs? Your cloud upfront costs are zero, and I think that's the benefit. You want to do test and dev. I think the cloud is a great place to do test and dev. But once you want to roll into production, and storage is kind of unique because it's kind of the unsaid thing. Compute costs flex. Compute costs go up, and then you turn machines down, and most people forget to turn machines down. But you turn machines up and you turn machines down, and when you turn up and down, you have a variable cost, and so you can save that cost if you go to the cloud. Storage, you don't ingest and delete. You ingest and you let it stay, right? And so storage costs are a fixed increasing cost over time. And so cloud is actually not a good place to have storage because your cost, you put the storage in and there's no flex. There is no, hey, I can turn it off. And so over a 3-year, 5-year period, you're significantly cheaper than AWS S3. I'd ask you to go to the math, but we're talking about 80%, 70% numbers, right? The numbers are pretty large, so very compelling from a cost perspective.
Awesome. And let's see, I think that question is now answered. Ooh. Okay. And yeah, I think those are all the questions that we have for today. But again, I highly recommend that all of you add Vishnu and myself on LinkedIn, follow NetApp and Dremio on LinkedIn to just constantly follow sort of the updates and insights from these technologies. And basically have a great day. And again, there'll be more Gnarly Data Waves always coming. So if you haven't subscribed to Gnarly Data Waves on iTunes and Spotify as a podcast to make sure that you never miss an episode, I recommend that you do that. And you all have a great day. And again, be thinking about that future for your data and how the Lakehouse can bring you lots of value. I'll see you next time.
Thanks, Alex. Thanks, everybody.